Hello everyone, this is KP the Math G, and I just want to make a quick announcement before we get into the lesson today. First of all, as always, I appreciate everyone here, everyone who tunes in, and you want to learn this and you have your confidence in me. That means so much to me. I do appreciate it. If you would like to subscribe and you haven't done so, just hit that subscribe button, and then if you want to hit a like, you can do that as well. I love likes. And if you want to make a comment, please do so. I appreciate the comments, whether they are, hey, thank you, great job, KP the Math G, or look, I have a question about this, or we could have, hey, nice job, but we could have done this better. And again, I always say that if you want to tell me that that you've got a better way, show me a better way. I'm open for that, but please, as I always say, you need to be correct. After today, I'm going to be gone from Wednesday through Sunday. Today is Tuesday, so after today, yes. It's my wife's birthday, and coming up. It'll be on the 28th on Sunday, but we're going to go out of town, and we're going to celebrate my wife's birthday. And I'm going to take her to the same cabin that we went to on our honeymoon. That's one of the two places that we're going to go. So it's really nice. And you want to see her? Okay, I got a picture. There she is right there. She and I right there. I tell you what, I'm blessed to have her. She's really my love, and I'm really blessed to have her. And hold on, let me put this back. There we go. I'm blessed to have her, and you get to that point in your life where you can't live without your spouse, and that's the way it should be, right? It should be that way. Okay. Anyway. That's my treat to her. I'm taking her on this little vacation. So I'll be gone, and no more videos until Monday of next week. Okay. Alright, anyway. Let's consider y is equal to 2x minus x squared. I want to revolve this about the x-axis. This is a volume of revolution. This is called the disk method. There's a disk method, and then there's a washer method. But if I have time today, and I will probably do another video, and I will show you how to do the volume. The volume of, well, it is going to be the volume, but it's going to be by the washer method. So anyway, as a washer leaves a hole, that's why it is called the washer method. A disk will not leave a hole. What happens is, if we revolve something, we're going to revolve it like this. It's going to be revolved, and it's going to go around this way like this, around this x-axis right here. It's going to spin around. It's going to do a circular motion, isn't it? Alright, so if we take the Ives-of interval to be somewhere right in here, it doesn't matter where we choose our Ives-of interval, alright, because we're going to sum all of these up, and it's going to take up this entire area. So what we're doing is we're rotating an entire area around like this, okay, like so. And before too long, I can give you a problem from one of the AP exams, and you can look that up too for yourself. But Right now we're dealing with a single curve. Later on we'll deal with more than one curve, two curves that intersect each other, and so on. But we're going to intersect this, we're going to rotate this, and it's going to rotate, I'll get a different color maybe. It's going to rotate in a circular motion, around and around like that. So that's what it is. So if it's going to be circular, the area of a circle, okay, is pi. Alright, the area of a circle, I better not use orange. Orange may not show up that well. I love orange, but not for writing on the board. So that's going to be equal to pi r squared. And if we deal with volume, we have to look at it from a three-dimensional standpoint. And we're going to look at the delta x. So if we look at the volume, it's going to be still the same. It's the area times delta x. Alright, this is delta x, which we turn that into dx. We are going to sum these up. I like to put the pi on the outside. And we're going to sum this up from, alright, notice that this can move from 0 to 2. We're going this way, since along the x-axis, perpendicular to the x-axis, we're going to move this. We could put this way over here, we could put it way over here, but I've chosen to put it right here, close, right at the middle. Alright, so here we go. This is going to be from 0 to 2. Alright, 0 to 2. And this height, by the way, and I've done this in other videos, but this is a height. That is my radius. Okay, actually in this case, sometimes we said height, but in this particular case, we're talking about a circle, so we're using this as r. That's our radius. Well, what is that? That's the height of this right here, isn't it? What is that? This is actually r. R is equal to 2x minus x squared. That is the r we're looking for. Okay, y is r. Okay. Alright, so that is 2x minus x squared. Ooh, I need to square that, don't I? Squared, and we're going to square that, and then dx. That's volume. Okay? The area times this thickness here is the volume. And that's what you have. You got everything here. Now, that's how you do it. The disk method is probably one of the easiest, if not the easiest, to do. And hopefully we'll get to do 2 examples today. Okay? Again, I can't say it enough. I appreciate all of you. And if this is your first time, I appreciate you too. Thank you so much. Now, let's square this. Now, how do we square this? Remember now, we're squaring. That means we're multiplying something by itself again, right? 2x, like that. Alright. And so we're going to deal with pi on the outside, 0 to 2. And let's multiply this. 2x times 2x is 4x squared. 2x times negative x squared is negative 2x to the third. Negative 2x to the third. This is a 1. 1 plus 2 is 3. Alright. This is also going to give me another negative 2x to the third. So negative 2x to the third. Some of you already probably have this written out. Alright, you could probably do this by eyesight, and that's good if you can. But if you can't, you can always do this. Alright, negative times a negative is a positive. The last term is positive. And x squared times x squared is x to the fourth. This is vital that you get this. Once you get it set up properly, you don't need to miss it here, do you? Alright, so let me erase this. You know, so I just wanted to show you. Okay. All right. I'm just going to leave this one here like this. All right. We can reduce this. Negative 2x cubed. Negative 2x cubed is negative 4x cubed. So negative 4x cubed, and then plus x4 plus x to the 4th dx. Nice. And that, you know, that's really the idea. You know how to integrate from here. Once you get down to this, we ought to be able to figure this out. I'll tell you the reason I wear a cap most of the time. Look at this scroungy looking hair, will you? I can never get that stuff to lay down properly, and I'm tempted to cut it all off. Not down, you know, not bald or anything, but just a little bit. My wife don't want that, so I'm gonna let it grow. Alright, so here we go. Don't forget the pi, by the way. Don't forget that. Alright, now 4x cubed over 3. Alright, remember, add 1 to the exponent, divide here. Same here. Oh, minus sign. Whoa. Minus 4x, add 1 to 3 is 4, over 4, like that. Of course, the 4's divide out, so this is just x to the 4th. Alright, so minus x to the 4th. Alright, plus x to the 5th over 5. And we are going from 0 to 2. Alright, so there it is. Now just plug in the answers. Pi, now 4 times 2 cubed. 4 times 2 cubed over 3 minus 4. No, I'm sorry, not 4, it's 2. 2 to the 4th power plus 2 to the 5th power over 5. Okay. That. Alright. Alright, like that. And I'm going to run out of room, but I'm not going to flip it over because I got the second problem on the board here. Let's see. 2 cubed is 8. 4 times 8 is 32. 2 cubed. 2 times 2 is 4, times 2 is 8. So 4 times 8 is 32. So pi, 32 over 3, minus 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. 2 to the 4th is 16. Plus 2 to the 5th. Well, if 2 to the 4th is 16, then times 1 more 2 is 32. So 32 over 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Alright, wow. Let's see if we can put this right in here. Okay, see if we can put some of that in here. Let's get a common denominator, shall we? Let's make this 15. So 5 times 3, 5 times 32. So let's see. 32 times 5. I don't have my calculator handy, so I'm just going to do it by hand. 2 5s are 10, 3 5s are 15, and then 1 is 16. So 160 over 15. Oh, don't forget that pi. Don't ever forget that. Alright, now 16 times 15. Alright, so I know that 15 times 15 is 225. So we're just multiplying by another 15, or adding another 15 to it. Well, anyway, let's just go. 6 times 5 is 30. 5 ones are 5, 6, 7, 8. 6 ones are 6. 1's 1. Alright, so minus 0. 8 and 6 is 14. Minus 240. Whoa. Over 15. Plus, alright, 3 times 5 is 15. And 3 times 32. So 32. Let me erase this. 32 times 15. 32 times, no, I'm sorry, 3 times 32. So 32 times 3. 3 2s are 6, so plus 96. 96. Alright. Let's hope that this adds up to be greater than this. Okay, so let's see. Our answer is going to be, alright, let's see, 160 plus 96. Well, we can probably subtract. Now let's add the 2 up, I guess. Well, it doesn't matter. Let's see. 240 minus 160. Now I know that the 240 is negative. So 0, 14 minus 6 is 8. And that's it. Negative 80. Is that right? So negative 80 plus 96. So negative 80. And then I've gotten plus 96. Alright, 16, isn't it? So all of this is equal to 16. I'm just going to put it right here. The answer is right here. So this one is going to be 16 pi over 15. Or 16 over 15. You can put the pi on the side like that. Don't forget that that's in cubic units, okay, because we're looking for the volume, okay, volume of revolution. Volume is going to be in cubic units, okay, so if you want to do that. But needless to say, 16 over 15. And I'm saying we did all this correctly. Let's see, 14 minus 6 is 8, so yeah, negative 80 here, and then plus 96. Yes, plus 96. Alright, there's that one. And that's basically how you do it. So it's pi r squared times delta x. And you got to square this, and we did all that. And then you do all the integrating and all that good stuff there. Okay, now again, remember that if you want to revolve something over the x-axis, this I subinterval is perpendicular to the x-axis, and you're rotating it like that, then you want to keep everything in terms of x. Always remember that. But let's look at this other one though. Got a little different one right here. This one is y is equal to x cubed, and it's bounded by the line y is equal to 8, bounded by the line x equals 0, which is the y-axis, and bounded by the curve itself. Okay? We want to revolve it this time about the y-axis, so I'm going to draw my I subinterval along the y-axis. This is going to be, well, it's not going to be delta x, now it's going to be delta y. Always remember that if your I subinterval, or if your thickness is on the y-axis, it's going to be delta y. We're going to solve for y. It's going to be rotated this way, like this. It's going to be rotated this way, and let me get a different color. Okay. It doesn't matter probably. Alright, it's going to be a circular motion right through here like this. It's going to make a circular rotation this way. It's going to go this way. And it's going to sweep out a solid. So we got to remember that just like on the other side, this one sweeps out a solid. It's solid. There's no hole here at all. Alright? When you sweep out it, you got to picture this in your mind that this is kind of like a bowl that you're rolling out here, okay? Alright, so you're just you're sweeping out a solid here. Alright, there's no holes. Now if there's a hole, then we got the washer method, but there's not a hole here. Alright, so let's go ahead. I do wish to erase this side because I need it to solve. Alright, well, this is in terms of x, so I need to solve it in terms of y. Okay, so let's go ahead and do that. Well, how do I get rid of x cubed? Yeah, you know, you've got to take the cube root, don't you? So the cube root of x cubed just gets rid of that. That's going to be x, but this side is the cube root of y, isn't it? So x is equal to the cube root of y, which we can really rewrite it as y. Remember the exponent, 1 over 3, like that. And that's really what we're looking for here. Because look, this observable is really going in the x direction. This distance right here, this radius r, is equal to x, isn't it? Just like over here on this other side, think about this. This is y. Alright, that observable right there is y. This radius is y. But now this radius here is x. See, that's how far that is from here to here. That's x. Well, x is equal to y to the 1/3. We have that well defined. Alright, so that's what I'm saying. If the observable is going to run parallel to the x-axis, you're going to solve for x. If the observable is going to run parallel to the y-axis, well, make sure you solve for y. In this case, it's already y. Okay? And that's what you got to do. Alright, well, let's continue with our volume. Alright, our volume is pi, and let's look at our integrate. Now, we're not integrating from 0 to 2. We're integrating this way. Our observable is going up and down. Well, this way, it's from 0 to 8. And I always had trouble with that. But the observable can move up and down from 0 to 8, and you know that makes it so much easier to understand. Now, r is that, but I've got to square r. Now dy. Simple as that. Pi r squared delta y, or dy. Okay, that's what this was right here. This was delta y here. Now we make it dy here when we set it up. And just always remember, from 0 to 8. Alright, here we go. Let's multiply this out. Let's kind of clean that up a little bit. From 0 to 8. Now, just multiply the numerators. So this is actually y to the 2/3 dy, isn't it? Okay? Alright, and then now this is equal to pi times, okay, let's see, we've got to add 1. Let's see, y to the 2/3 plus, remember, I always like to add 1. I use the same denominator. Alright, this is equal to y to the 5/3 divided by 5/3, but remember, you can just flip the 5/3 over and make this 3/5. Flip it over. Always do that. Just make your life a little bit simpler. And we're going from 0 to 8. Alright, so actually if we want to, we can put the 3/5 on the outside right here. So this is 3/5 pi. Now I'm going to plug in the 8. This is the cube root of 8. Remember this 3 on the bottom is the index. The cube root of 8, but I'm going to raise it to the 5th power. Okay, like that. minus the cube root of 0. Alright, but I'm going to raise that to the 5th power, but we know what that is anyway, right? That's 0. Alright, so here we got it. It's 3/5, 3/5 pi. Anytime you can take something out, just go ahead and do it. Make your life a little simpler. Alright, now cube root of 8. What times what gives you 8? Yeah, that's right, 2. So 2 to the 5th power minus 0. Alright, now this is equal to 3/5 pi. 2 to the 5th is 32, like we found out last time. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So times 32 over, that's it, just 32. And if you want to write it over 1, you can. Alright, we can't divide out, so let's see. 3 times 32, that's going to be 3 2s are 6, 3 3s are 9, 96 over 5 pi. And that's it. 96 over yeah. Yep. That's it. I actually worked it out and got the incorrect answer. The reason being is I did not square the 1/3 here and make that 2/3. So I started off with 1/3. Leave it to me. But anyway, this is correct here. You always got to square pi r squared, that's your circle, and then the thickness. Always remember that. Alright, and that's it. That's what you got to remember. Pi r squared. Now in the next video that I'll do, which hopefully I might get to do when my wife is sleeping right now, so I get to do things like that. Otherwise, once she gets up, I want to be with her for a little bit, and that's understandable, right? Okay. Okay, again, this is KP the Math G. Don't forget to subscribe if you would like to. I'm just here to help, though, whether you want to subscribe or not, but it'd be nice if you did, but okay. And also, the like button is good. Make a comment if you like to, and I do appreciate you. I appreciate everyone who has tuned in, and I notice that I do get a lot of people looking at this, and it's very much appreciated. I do not take this for granted. I do not take you for granted. So again, very much appreciative of you. Again, KP the Math G signing off. Have a great day.